So to find an integral that represents the area, it'd be nice to first have a sketch of the graph. So this is a lemicon, and one thing, because I don't have all the polar equations memorized by heart, but I usually, if I don't know what the graph looks like, I'll plot some values, and then I'll start to see a pattern. But if you just do a quick Google search for common polar equation graphs, you'll see it's a lemicon. It meets this structure, and so it's going to have one of these types of shapes. So we don't know exactly what the shape will be without plugging in some points and trying to be really careful, or maybe analyzing this further, but we don't have to. Okay, the objective is to determine the area, determine a definite integral that represents the area of the region below the polar axis. So this is the polar axis. So this is the region below the polar axis. So this starts at pi. Theta of 0 is over here. So our regions, we want to start our rotation at pi, and then keep rotating until we've gone to the limit of our polar region integration. We stop at 2 pi because then we made a full revolution. So we want to go from pi to 2 pi. So using the formula for the area of a region of a polar equation, we're integrating from an angle of pi to 2 pi. And then our r is 9 minus sine theta. So we're supposed to square that. So I think that's it, or you could just rewrite it like this, and I think that's all the question wanted, was to set up the integral. We don't have to actually evaluate the integral.